guys, there's 5 problems. Each problem is a situation that you have seen and that you will see. So make sure you're paying attention. If you get stuck, refer back to the sheet. If we take a look, we have our first problem here. Each side has an exponent. This should be when you are thinking change of base. Okay, when you have each side has an exponent, you should be thinking change of base. So we have 8 and 32. What base would they have in common? 2. So 8 to what power, or not, 2 to what power would give you 8? So 2 cubed is 8, so then I'm going to bring over my exponent that was there, the x minus 5, equal to 2 to what power would give you 32?
5.
2 to the 5th, with the same exponent of x minus 7 there. Now that I have a common base, what can I do? Solve how?
You're going to cross out the 2's and then you're going to get 3x minus 15. Yeah, for real.
All right, good. Set your exponents equal to each other when you have the same base. Some of you guys might skip this step and go right into distributing. If you did, go ahead and finish solving. You should be able to solve this.
Answers time.
Raise your hand if you have an answer for me. Tatiana? X equals 10. Do we have questions on this one? Jose, question?
Wait, never mind.
You're good?
Yeah.
All right, I kind of skipped the step of subtracting 3x from both sides and adding 35 to both sides. Okay?
You need to be listening because this is like a gift to give you a review on how to do every one of these problems. This should be like one of the most important sheets that you reference this whole entire rest of the chapter. Because it tells you step by step. You have a test next Friday. Come on.
Not only do we give you the steps, but we give you an example and we solve it out with you. All right, number 2, we have log equal to log. What do we do?
Just cross out the log and set the thingies equal to each other.
The logs are the same, so we cross them out. And we're going to take our arguments, 2x plus 5 equal to 8x minus 31. You should be able to solve this now. Go ahead and solve that. Hmm? 5 times 7 is 37. Or 35. Subtract 2x from both sides, add 31 to both sides, so you get 36 equal to 6x. So what does x equal? 6. X equals 6. Okay? Always, ladies and gentlemen, make sure you check your answers. If I did plug 6 into my x's, would I get a good argument?
Yeah.
Yes. Therefore, all we need to know is that our argument does not end up being negative. Okay? All right, number 3. What is the first thing I should do? Good, I want to get this exponential expression alone, so I need to add 4 to both sides. So I'll end up with getting 5 to the 2x plus 1 equal to 34. Can 5 and 34 be written with the same base?
No.
No, so what do I do? The heart method, convert to log. Log base 5 of 34 is equal to our exponent, 2x plus 1.
So then you do that one of the things in the calculator.
Good, we need to type it into the calculator. Change of base. Who can tell me what is log base 5 of 34? 2.19 from the calculator equal.
Wait, how do you type it in on your calculator?
So, see, do I have my calculator pulled up?
Alpha window. Green button, window. Green button, alpha, window.
I need a calculator.
And then it's number 5.
Wait, what is that green button?
Alpha window. So the second one from the top. Then number 5.
Oh, so it's like a custom.
Or you can also write it as log of 34 over divided by log of 5. In your calculator, give you the same thing. So either way you do it, if you divide 2 logs or you do the base change in there, you can get it. All right, subtract 1 from both sides, so you'll get 119 equals 2x. What is 119 divided by 2?
0.61.
Wait.
It's like 0.595.
X equals 0.595,
0.595.
which we could round to x equals 0.60. Ladies and gentlemen, I'm going to tell you now, on your homework tonight, it says round to the hundredths. That's how many decimal places? 2. So if you tell me 0.6, it's wrong because you need 2 decimal places. So even if it's a 0, you should have 2 decimal places. Yes? But we want to round, so you have to round that 9 up. Okay? Because that's why I put this down here. 0.595, the 5 after the 9 tells you to round up. Okay? Questions on those ones? All right, we have 2 more. We have log equal to a number. What do we do when a log equal to a number? The heart method. Convert to exponential. So 4 to the power of 3 is equal to our argument, 3x minus 17. Good. 4 to the third is 64. You should be able to solve this from here. Go ahead and finish solving that. Add 17 to both sides. You'll get 81 equal to 3x. Divide by 3. What does x equal? X equals 27. All right, last one. I see 2 logs on one side. When you see 2 logs on one side, what should you do? We need to condense to 1. Since we see addition, what operation does it actually tell me to do? Multiplication. So I'm going to come here and write it as log base 2. Guys, there's a lot of talking going on. Log base 2. X times x is x squared. X times 6 is 6x equal to 4. So all I did was change that one side. Log equal to a number. What do we do? Part method. 2 to the power of 4 is equal to my argument, x squared plus 6x. If we take a look here, we have, what do you notice? What do we have? We have a factoring problem. How do we know it's a factoring problem? We have 3 different terms here. We have an x squared, we have an x, and we have a just number. What is 2 to the 4th? 16. So I'm going to have the 16. I'm going to move that 16 to the other side, so I'm going to get subtracted and get 0 is equal to x squared plus 6x minus 16. If you need a refresher of how to factor, you got to find factors of negative 16 that add to 6.
Negative 8 and 2.
Which one? Negative 8 and positive 2 or positive?
Negative 2 and positive.
Negative 2 and positive 8 because we want to add up to a positive. So if we add these, 8 plus negative 2 gives us a positive 6. Okay, you can always check that in your calculator too. So I'm going to come here and say I have 0 equals x plus 8, x minus 2. The x plus 8 would give me x equals, and the x minus 2 would give me x equals 2. This is a very important one to check. You should always be checking all answers to make sure they work, but especially when you factor. If I plugged in 2, would I get a positive argument in each of them?
Yeah.
Okay, what if I plugged in negative 8? No, if I plugged in negative 8 here into just this piece right there, Right there you get a negative argument. Therefore, it does not work. I'm going to cross it out. Make sure you cross it out. And I'm going to come over here and say my answer is x equals 2. Questions on this? That's our notes for today. It's just a review of all 5 different types of problems. Jose?
So, originally when I did that problem, when you said do the hard method,
Mm-hmm.
I took log base 2 and then I drew the arrow to the 3.
Where's a 3?
Or not the 3, sorry, the 4.
Okay.
And then I plugged it in with the thing that you showed us and I got 2. So like why wouldn't you plug it in like in the other one? When we do the base thing of the arrow.
So you plugged it in as a log base 2 of 4.
Yeah, 2 and 4 and I got 2.
Because we're not going to log. We're already in log, so we're going to exponential.
Okay.
So yes, that is correct. Like log base 2 of 4 is 2, but that's not what we're converting to.
Okay.
Because we already have a log. If you're already in log method, then you don't want to convert to log.
Okay.
Okay? Other questions? That's a good question. No, we're good? All right, then I am going to come around and pair you guys